We have one more type of summation that we're going to talk about. So the focus of the previous lesson was to look at what's called a Riemann sum. And there were three different types of Riemann sums: right, left, and midpoint. Well, we actually have one more type of sum. It's not usually called a Riemann sum. It's called a trapezoidal sum. What you're going to find is the trapezoidal sum is actually more accurate than either of the right or left Riemann sums, because it creates trapezoids under the area under the curve instead of creating rectangles. So if you think about area of a trapezoid, it is 1/2 the average of the two bases and then times the height. So we can actually have the Delta Math program draw these trapezoids so you get a better idea of how they work. So they have to give you very similar information. They have to tell you what interval we're starting and stopping at. So this one is going from 0 to 2. They also have to tell you how much we're partitioning it. So we're going to split it up into 4 subintervals, so 4 trapezoids. So 2 units divided by 4, that means each subinterval is going to be 0.5. And it will again draw them for you, but it's going to start out drawing them as rectangles. Here's how we draw them as trapezoids. What we're going to do is we're going to pull each side of the interval. So the first one goes from 0 to 1. We're going to pull each side to the function. And what it'll create is it'll create a trapezoid. The height of the trapezoid is this 0.5. The bases of the trapezoid are going to be the two pieces that we drug up from the axis up to the function. So they're going to be those two y values. Then we're going to do the same thing for the second one. We're going to come up to the function, and then we're going to come up to the function here. And then we're going to do the same thing here. Come up to the function, come up to the function. You can already see how good of an approximation this is because you have very little excess and very little missing. So there are my 4 trapezoids. Again, the bases are going to be these pieces that are parallel that we find by going up to the function. The height of my trapezoid is going to be 0.5. So now as far as how it approximates it. So with trapezoidal function, it doesn't have anything to do with increasing and decreasing. Instead, it has to do with the concavity of the graph. If the graph is concave up, this one's not concave up, this one's concave down. If the graph is concave up, then the trapezoids actually overestimate the actual region. If the graph is concave down, which is what you're looking at here, my graphs will underestimate it. So this is an underestimate or under approximation because the concavity is downwards, all depending on concavity, not depending on increasing or decreasing like the Riemann ones were. So let me show you another one. So this one is going from 2 to 8. It is splitting it up into 3 intervals. So 2 to 8, that's 6 units long, split 3 ways. Each one's going to be 2 wide, and it'll draw them for you. We're going to come up with my trapezoids, putting each end there. So there's my first trapezoid. Too far. There's my second trapezoid. And there's my third trapezoid. I am again under approximating because the concavity is again downward. Let me see if I can find a concave up one for you just so you can see how it looks a little differently. Nope, that's downward. Downward. There's got to be one here somewhere. Trapezoidal. Downward. I swear it exists. Doesn't want to show me an upward trapezoidal. Hey, there we go. So this one is going from 2 to 6, 4 subintervals. So that means each one is 1 unit wide. As I draw them, I got to drop it down here. So here's my first trapezoid. Second trapezoid. Third trapezoid. And finally, fourth trapezoid. Again, really good approximation. This one will over approximate it though because it is concave up. So that is how we create trapezoids. Visually, I'll show you how to do it with an equation in the next video. What did I do? had all that right. Oh, I didn't draw one of my ends correctly. Be careful when you're pulling them down that you actually hit that, but I did have the rest of it right. So that is a basic graphical trapezoidal. I'll do an equation trapezoidal next.